If you've ever thought about how data moves across oceans, across continents, at pretty much the speed of light, you've probably glossed over a really crucial component, the optical amplifier. Today, we're doing a deep dive into that exact tech, and we're using the Thor Broadcast F-EDFA-20 unit as our case study.
Exactly. Our mission today is to get past the spec sheet, and really understand the engineering that makes all modern fiber optic communication work. We're going to break down how this specific unit handles DWDM traffic. And most importantly, we're going to hit that core claim they make: virtually zero latency.
That's the big headline, right? Because distance, we all know, it kills signal strength. And the old way was to what? Convert the light back to electricity, clean it up, send it on its way.
Which adds delay, a noticeable delay.
So how does this little box get around that fundamental problem?
Well, the answer is right in the name. EDFA. It's an Erbium-Doped Fiber Amplifier. This specific model is built for dense wavelengths division multiplexing, specifically that 1550 nanometer window, which is kind of the sweet spot for fiber optics.
And for anyone who needs a quick refresher, DWDM is basically how engineers cram dozens of different data channels onto a single strand of fiber. They just use slightly different colors or wavelengths of light for each one.
Precisely. And the magic here, or I should say the engineering, is that this amplifier boosts the signal optically. It never converts that light into an electrical signal and back again.
So it just makes the light that's already there stronger.
Exactly. That direct light-to-light amplification is the whole key, is what gives you virtually zero processing delay, whether you're sending data between continents or just across a big campus.
Okay, so that direct amplification maintains the speed. But what about the quality of that signal? I noticed the source makes a point of saying this EDFA uses OFS erbium-doped fiber, and they even say it's made in America. From a technical standpoint, how much does the fiber itself matter versus, say, just the erbium in it?
Oh, it's paramount. The purity of the fiber, the manufacturing process, it's all critical. You can think of the erbium as the active ingredient.
Right.
The high-quality pump laser inside the unit, it energizes those erbium atoms. Then, as the original signal, the photons pass by, those energized atoms release new identical photons.
So it's a coherent light boosting itself.
That's a great way to put it.
That's a fascinating look under the hood. So let's connect that to flexibility. The source says this works with any optical signal in that 1550 band, regardless of the protocol or the data rate.
And that universal compatibility is a massive advantage. I mean, it doesn't care if you're sending high-speed Ethernet or even older analog RF over fiber. As long as the wavelength is right, it gets amplified.
And what about that 20 dBm optical power output? That sounds like a stability metric, is that right?
Precisely. You can think of it like a high-end booster pump for water.
Yeah.
It guarantees the output pressure. The power is always exactly 20 dBm. It doesn't matter if the signal coming in is strong, say plus 10 dBm, or quite weak, maybe negative 10 dBm.
So you get that consistent, guaranteed power down the line. That's a foundation for reliability.
It is.
Okay, moving on to the more practical side. The system specs. It's a standard 1RU rack mount, uses about 50 watts. But what about managing this thing remotely? I mean, this is critical infrastructure.
For sure. For network management, it has a basic SNMP system through an RJ45 port and also an RS-232 interface.
Yeah.
SNMP lets an engineer monitor everything remotely. They can check the health, the metrics, without ever having to physically go to the rack.
Which is essential for global networks.
And there's a really important safeguard built in, too.
The warning alarm.
Yeah, the signal detect warning alarm. If the input signal just drops to zero for some reason, the system automatically switches off that expensive pump laser.
To protect it.
To protect it, exactly.
That's...
It keeps the heart of the EDFA from degrading when it's not being used, which contributes to a really long operational life.
All right, let's wrap this up. Let's talk about what this really means for you, the listener. These specialized amplifiers, they're the unsung heroes of fast, reliable data. By boosting the light signal directly, they make sure our information stays strong across huge distances without ever slowing down for a pit stop.
It's true. And when you see specifications like guaranteed 20 dBm output and virtually zero latency, you realize this isn't just about streaming video faster. This is what enables real-time telemedicine, global financial transactions, huge collaborative research projects. So I guess the thought to leave you with is this. If our knowledge and our economy are built on connectivity, what does it mean when the hardware itself is designed around the principle of maintaining perfect data integrity over any distance?